All right, for our third section, we're going to talk about terminology and also systems as models. So the most common thing you're going to see in upper level math as far as notation will be f of x equals, let's just say, for example, 3x plus 4. Well, this looks a whole lot like y equals 3x plus 4. So we're going to discuss briefly why that's the case, why it's important, and why we need to be familiar with this. Because if you're okay with doing this, you should be perfectly fine doing this. So here, what we're saying is that as x changes, y will also change. For example, if I said that x equaled 1, then my y, I put 1 in here, this becomes 3, my y equals 7. What if x equaled 2? Well, this becomes 6, this becomes 10. Y is changing because x is changing. So this letter that's in here and that's used in this equation over here is called the independent variable. And the what's over here, the y, is called the dependent variable. Sometimes it's hard to tell them apart, but this is one way you can figure it out, or you can ask yourself questions like this. If I want to talk about the total number of calories I eat in a day, so I want to talk about total calories, and I want to figure my total calories as they relate to the number of cookies I eat. Ask yourself, is the number of cookies that I eat determined by how many calories I had? Or is how many calories I had determined by how many cookies I ate? One of those will sound more normal. And the fact of the matter is, total calories is dependent on cookies. And the number of cookies you eat is independent of the number of calories you had. It's kind of a weird thing because you're both related. I mean, I guess if you knew how many calories you ate, you know how much was in a cookie, you could figure out how many you ate. But that's not really how they work. And so getting dependent and independent down in your head, the number of calories you eat in a day is dependent on the number of cookies that you had, or the number of Twinkies, or whatever it is. So for example, how much money a factory can make is dependent on how much product they can put out. So if you have profit and widgets, like things that a factory makes, the profit depends on the widgets. The widgets don't depend on the profit. Oh, you made $1,000 in profit? That means that you must make 2,000 widgets. That's not how it works. The profit is dependent on the widgets. You made 2,000 widgets, therefore you have 2,000 or 4,000 profit, or however it works. So we have dependent, independent. And when we read this, we're saying that this, whatever this is over here, whatever is represented here, whether it's y, this could be profit, this could be the total calories, whatever this is based on this value. It's a function of this value. So in this situation, the y value is a function, this function of x. So this determines what happens to y. This is a function of x, meaning that x is what's independent, and what you're figuring out over here is dependent upon it. This is the number of widgets. This is the amount of profit. Okay, so we want to go ahead and I'm thinking example 1, where we have f of x equals 3. Let me just write it down. We have f of x equals 3x squared, and g of x equals 4x plus 1. It means as x changes, whatever this represents, whether it's profit or whatever, this is going to change depending on how much. Like how many contracts you get determines how much you make. How many widgets you sell determines how much you make. How many hamburgers you eat determines how full you feel. These type of things. This is independent, this is dependent. So if we have something like, okay, for the first thing we have f of 5. Well, what we want to imagine f of 5 is, we're going to use, this is f, so we need to use this. We have f of x equaling 3x squared. For these situations, what I do is I go ahead and I replace my x with an empty parenthesis, because really all it is a placeholder. Then I put this 5 wherever it was. So f of 5 is the same thing as 75, because 5 squared is 25 times 3 is 75. So you kind of want to think about the x as a placeholder more than anything else. So let's do that with g of 5. So we have g of 5. That would mean you have 4 times some value plus 1. What's that value? They told us it was 5. So now it's 20 plus 1, or 21. Okay. In the next one, we have f of 2 over g of 2. What does that equal? That equals 3 times 2 squared over 4 times 2 plus 1, which is 412 over 9. And the last one, we have f of g of 6. This is probably the hardest one. So what this would be the same as the same f of, what is g of 6? G of 6 is 4 times 6 plus 1, which is 25. So I could erase that g of 6 and put 25 there. And f of 25 is 3 times 25 squared. Any discomfort with this concept will be a terrible thing later on. So we definitely need to make sure that you have this concept. So for the second example, suppose that your family is going to buy a new air conditioning unit. I highly recommend you read along, by the way, when I read these problems. One brand cost $1,800 to buy. I'm just going to write that down for fun. And $60 a month to operate. A more expensive brand costs $2,600 to buy. And it's more efficient. You only need $50 a month to operate that. Now, we want X to be the number of months since we purchased the unit, because the cost of ownership is determined by how many months you've had it. And we want F of X to be the number of dollars spent. John, shut the laundry room door. Oh, that's not the laundry. It's starting to rain. The laundry's not running, is it? Okay. We want the X to be the total number of months. So we're going to say X is months. And we're going to say F of X is going to equal the cheaper unit. And we're going to say G of X is the expensive unit, or the more efficient unit. Okay, so now what we want to do is we want to talk about expressing this in an equation. So for the cheap one, we know the cost of running that thing is the original investment of $1,800 plus $60 for every month it's in service. This looks a whole lot like a line to me. X is to the first power. If we move this around to 60x plus 1,800, now we have it in slope-intercept form. You could think of this as y equaling that. But we're going to think about it as how much that unit cost depends on how many months you had it, period. This cost is dependent on how many months you've had it. So let's talk about g of x. For g of x, we're going to have the initial investment plus $50 a month. Well, let's go ahead and put that in slope-intercept form, so that you can clearly see that this line represents how much money you're spending on that, or that you've spent on that unit. And we could graph this thing. They have the graph there on the bottom of the page, and I'm assuming that you guys are good with graphing. I don't want to spend time doing that. But we want to talk about, where do these break even? Where they break even are when the lines cross. When the lines cross is when you spent the same amount of money on both units. And when you spent the same amount of money on both units, after that, the more efficient unit every month will be cheaper. And each month will add more and more savings to your pocketbook. So let's talk about how that looks. I just erased my equations. Okay, so for, let's just do this. The amount that you spent is 60x plus 1,800. And the amount that you spent is 50x plus 1,800. Oh, sorry, plus 2,600. So what we want to do right now is solve these. We could solve them by adding them together, but if y is on, if y is here and it equals 60x plus 1800, and y is here and it equals 50x plus 2600, if this y actually equals this, I can take this number and just plop it on the other side of the scale. So that's what I'm going to do. I'm going to say 50x plus 2600 equals 60x plus 1800. So here I'm going to bring the 50 this way, get 10x. I'll bring the 1800 this way, 800, x equals 80. So after 80 months, what has happened? Well, at 80 months, we spent the same amount of money on each one. So at 80 months, you break even if you would spent the more expensive one. And then you have to ask yourself, it's an air conditioning unit. Does it make sense to have an air conditioning unit for 80 months, which is approximately, was almost 7 years? Yes, it does. So that being the case, if you had extra money that you could put towards it, I would buy the more expensive one. So I recommend reading through those examples that they have in the book, making sure you understand them, and then completing your homework.